All right, so before we kick off with everything that we do have to do today, we're going to start off with a review of our data types. So let's assume we wanted, like, I don't know, an integer. We can always go let x. If we want to specify the type, we can go i32. We can go u8, or we can just stick with a default value. And that's it. And its default is going to be i32. So we have our integers signed, which all start with I. So i8, i16, i32, i64, i128, and isize. If we wanted an unsigned integer, we got our u8, u16, u32, u64, u128, and usize. For our floating points, if we needed a floating point, we can always go with our let pi f 64 equals 3.14159. And we've got our pi value. It's currently yellow underlined because we're not using it. If we wanted our booleans, we've got our let is active bool equal true. If it's inactive, it would be false. So true, false, 1, 0. Yes, no. Our char. So let's go let letter equal A. Now what is it assigned as? A char. Which is characters, 4-byte Unicode scalar. We've got our compound types as well, so we got our tuples. So let's go let tup i32 f64 char equal our 10 3.14 and our a. Tuple being a fixed size collection of values. For arrays, let's do a let array. We are going to assign types to it. So i32 5 equals 1, 2, 3, 4, 5, and there we go. Now let's do our structs. So let's go struct person name string age u8 let person equal person name string from Alice, whoops, and age 30. Structs are custom data types grouping multiple fields into one. The next thing we're going to do is our enum. So let's go enum direction. And here we have north, south, east, west, And then let dir equal direction north. And enums are types that can be one of several values. So we set specific values for it. For our flow control, we're going to do a couple things here. So let number equal 5. This is going to be a conditional. So if number is less than 10, print line number is less than 10. We have our else in here. Print ln number is greater than 10. So that is our if statement conditional. The next thing we're going to do is a standard loop, which is going to be an infinite loop. So loop print line this will run forever. Our next one is going to be our while conditional loop. So let mutable, so this is going to be a mutable variable, counter equals 0 while counter is less than 5. Print ln counter plus equal 1. So that's our while loop, which is a conditional loop. It doesn't run forever. It runs until it meets a specific condition. The next one we're going to do is a for loop. So for I in 0 to 5, print line I is and then we have another one here. We're going to loop through an array, so 10, 20, 30. For value in array, print line value and there we go. The next thing we're going to do is going to be a match, which is similar to a switch statement. So let number equal 3 match number. So here we're going to have 1 print line 1 2 print line 2 print line 3, and then let's go defaults. Print line other number of bounds. And that's our match statement. Let's just cover a little bit of basic input-output before we continue on with what I actually want to cover right now, which is going to be, well, you'll see in a minute. IO. I spelled STD, so we're going to pull from the standard library input and output, and let's do let mute input equal string new print line enter something IO std in dot read line and mute input. Let's throw in an exception. Expect failed to read line. That way, if nothing is put in, we're good to go. And then print line. You entered. And then input. So that's our basic IO. So that's just a review of what we covered last time. We've got our data types and our basic input output. The next thing we're going to be covering is our ownership and how it's implemented. So we're going to start off with just standard ownership. This is going to be our pizza, and we're just going to express ownership in general. So let's start with our eat pizza function. So function eat pizza string print line eating pizza. There we go. So the next thing we're going to do here is we're going to actually put it within our main method here, or our main function. Pepperoni. Wow, I spelled pepperoni wrong. There we go. And then let's go eat pizza. There we go. So what do we got going on here though? We have our ownership of the pizza. So with that variable, we establish our ownership. In the second one, ownership of the pizza is moved to the eat pizza function. In the eat pizza function, it then prints it out. So here we have our immutable borrowing. So show pizza just borrows the pizza to show it off, but you still own it in main. After show pizza is done, you will still have the pizza and you can still use it again. Cargo, run. There we go. So here we have immutable borrow. So the add topping borrows the pizza and modifies it by adding extra cheese. You can still use pizza in main, but while the pizza is borrowed as mutable, no one else can borrow it until it's returned. Cargo, run. And there we go. Pizza with toppings, plain pizza with extra cheese. Here we create a slice of the pizza string from index 0 to 9, which refers to the substring of vegetarian. The slice is a reference, so it doesn't take ownership of the entire string. So if we run this, cargo run, there we go, pizza slice vegetaria. And then here we're going to get a slice of pizza. Each slice is stored in an array. So in this case, we do have an array representing the pizza slices. We take a slice of the array referencing only the first two slices without taking ownership over the whole array. So ownership in the sense of pizza, you own the entire pizza If you give it away, you no longer have access to it. Borrowing, on the other hand, you let others see or modify the pizza temporarily, but you still retain the ownership. An immutable borrow, people can look at the pizza, but not change it. A mutable borrow, someone can modify the pizza, but only one person at a time can do that. Our slices, you take a part of the pizza or a slice and reference it without owning or modifying the whole pizza.